Scott Gayfield, Project Manager.
Everett Dutton, SolidWorks and AEV Design.
Jack Lobb, Programming and Media.
Matt Stubbe, Technician and 3D Printing Consultant.
And we are Group H.
The purpose of the project was to develop an advanced energy vehicle, or AEV, to move along a track. It had to travel to a gate, wait for it to open, pick up cargo, travel back to the gate, and finally back to the start. This was set to a Star Wars theme, in which the cargo is an R2-D2 unit. First, we will discuss the various design stages that the AEV went through the duration of the project. A couple of different ideas were brainstormed and written down. Some of these became working designs later on. First, the team utilized an X-shaped design. This allowed for two 3-inch propellers and plenty of space for all the components, as well as inherent balance. Unfortunately, due to its unnecessarily large size, it hit the gate with its right propeller, and it was a bit too heavy at 262 grams. Next, the team tested a rectangular design. This was done in order to test the viability of using one propeller. Unfortunately, due to the location of its components, the design was unbalanced, and the weight compared to the X-shape was not significantly lower. From here, the team modeled a full unibody design using SolidWorks. This completed the 3D modeling requirement of the project and allowed for very tidy and compact construction. The design used two motors facing in opposite directions, so each motor could be used to go one direction. The design had a much lower mass than the previous designs, at 230 grams. Unfortunately, there was too much infill on the print, and the design was a bit stronger than it needed to be. To finalize the design, the team went back into SolidWorks and cut out as much mass as possible and printed with a lower fill, creating an ultralight unibody design. This cut out roughly 10 grams from the previous design. While the design was slightly less durable, it was still strong enough to complete the course. Next, we will discuss the testing results and the strategies behind the programming of the AEV. These are the power versus time graphs for each respective AEV design. For the first three designs, the motors were used to brake the AEV. This resulted in the power spikes in the graphs. However, for the final design, the code was modified so that the AEV would coast to a stop. This meant that the AEV would use significantly less power than the other method. This can be seen in the final graph, where the AEV is simply ran at a constant power level until it has to stop. This animation shows the final design of the AEV and how its components fit together. The AEV project strengthened skills in working with groups and creative design. It provided a backdrop for working to improve things such as power efficiency and coding. The project was an invaluable lesson in the fundamentals of engineering.